Okay, and we're rolling. Okay, people, we're going to try this again. So don't groan, don't complain at me, we're trying it out. So as you can tell, section 5.1 is a little hefty. This is going to take us a couple days, so we're not going to do all this today, but what I'll do is like what I normally do when we have a big assignment or a big section is I'll break it up. You'll probably have a bit of time tomorrow to work on homework, which I know this weekend's a busy weekend, and so that way we can hopefully get most of it done. So we're going to start chapter 5, and 5 is all about inverse trig functions. And also we do trigonometric equations, which I love. So here we go. The first thing we have to remind ourselves is what is an inverse function? Forget about the trig part of it. What is an inverse function? So remember, 1-to-1. Hopefully right now you're like, is a function, has an inverse. Is a function, has an inverse. And if you weren't, here it is. But how do you tell if something is 1-to-1? So think about that for a second. Okay, we're done thinking, I'm bored. If a function is 1-to-1, that means it passes the vertical and horizontal line tests. Oh, you can't see that over there, so I'm gonna move it. And there it is. Okay. And also that, remember when we found the inverse of functions, we're going to remind ourselves here in a minute. You flip your x's and your y's. Well, remember, if we flip our x's and our y's, that means also our domain and our range also flip. So, here we go. So here's an example. I called it example A because I kind of made this up a little. I input this in. It's not in the notes of the section, so it's a little special. So for the 1-to-1 function, and if you think about what this looks like a straight line, y-intercept of -3, slope of 2. It passes the vertical, so if you're thinking about a line that looks like something like, it passes the vertical and the horizontal line test. It only crosses one time, right? So let's go ahead and find the f inverse. So here's our function, and to find the inverse, we switch the x and the y. Make it look like that. Hopefully you guys are like, oh yeah, I've done this before, because we have. And then we solve for y. So to solve for y, I'm going to add the 3, and then I'm going to divide by 2. So the inverse function is x plus 3 all over 2. And now they want us to check by doing this. And remember what these are called? It's called a composition. So those are composition. That's like the f of g stuff. So once again, we have also done that. We're doing it again. So here we go. Let's do f inverse of x. So we take our f function, and wherever I see an x, I put the inverse. And now let's simplify it. So what happens to these 2's? They cancel, and we're left with x plus 3 minus 3. Plus 3 minus 3. Oopsies. Backwards. Equals x. Okay. And that's what it should have equaled according to the directions. And now we got to do it the other way. We got to do f inverse of f and see if we get the same thing. So of course I did not make that space big enough. This is the first time I've done these ones. So let me just do that quickly. Hopefully you guys wrote smaller than I did. Just do it right here. So now what we're doing is we're doing this guy. So we're going to take our inverse function, which we just found is this. And instead of an x, I'm going to put 2x minus 3. And we're going to simplify. So 2x minus 3 plus 3 is 2x over 2 is x. I hope I didn't go too fast. We have done this before. It's probably done this 2 or 3 times now in your life as being taught new topics. So I'm going a little bit quicker. And this isn't the most important part of this, but here we go. Okay. So that's one way to talk about inverses. Another way is if they give you a set of points, these are actually called sets. In order to decide whether it's one-to-one, what we have to look at is, first of all, look and see if it passed the vertical line test. So if you look at G, the domain of G, domain is the x value. So what's one x value that we have? We have a -2. We have a 0. We have a 2. And let's see what our range is. Our range is 4. We have a 0. We have another 4. Don't list it twice. And one way to do this is draw arrows. -2 goes to 4, so I drew an arrow. 0 goes to 0, and 2 goes to 4. As long as none of these go to 2 places, we're okay. Well, now let's look at the inverse. The inverse is when we flip our x's and our y's. So what we would have is we'd have 4, -2. I just flipped these over, or flipped them around. Oh, I love flipping 0, 0. It's still 0, 0. And then we'll flip this one as well. Okay, so now let's do our little chart thing here. So our domain, we have a 4, we have a 0, and another 4. Okay, so we only got to list it once. And then for our domain, we have range, we have -2, 0, and 2. Is everybody okay to that point? I hope so, because I cannot see you. So I'm just going to rest a minute and let you catch up. But actually catch up. Don't start horsing around. I know that's what you're doing. Okay, so now let's draw our arrows. So this first 4 went to a -2. The 0 went to a 0. Okay, that's not special. Now this 4 also went to 2. So what happened to our 4? Our 4 tried to split and go to 2 places at one time. So this is not one-to-one. So that means it is a function, but it does not have an inverse because it failed right here. Okay. So I would like you to try the next one by yourself. Okay, I'm bored. I'm sitting here by myself in the dark. Okay, let's move on. So if you look here, do we have any x's that repeat? Nope. Okay. So if none of the x's repeat, what can we say? Well, we can say it is a function. So let's look at the inverse. So let's look at these x's. Do any of those repeat? 2, 3, no. So over here, if you look at the first example we did, if you notice on the G inverse, we had a 4. The 4 got repeated, and they went to different values. That made it not a function. Now look here. Did any of them repeat? No. So that means it's going to pass both the vertical and horizontal. So it is one-to-one. Okay. Okay, so let's try example C here. So they give us a function, and the first thing we need to do is find the inverse. So here's the function. And now we're going to find the inverse. So switch your x's and your y's. Okay, so solve for y. So the first thing I'm going to do is minus the 1. And then how do we undo a divide by 3? We got to multiply by 3. So h inverse of x is equal to 3x minus 3. I just distributed the 3 over here. Okay, so that seemed pretty straightforward. So now you're like, well, what is this h inverse of 5? So what did we replace? We replaced the x with a 5. So what are we going to replace this x with? You guessed it, a 5. So 3 times 5? 15. Great. Minus 3, 12. Lovely. Good job. So hopefully the down and dirty there of the inverse functions jogged your memory a little bit. So there you are. Okay, so now we're actually going to go ahead and do the trig stuff with it. So it might be helpful if you had your books open to kind of look at pictures, which are going to be, as you know, better than mine. So let's see, I'm trying to find the page number. And this way I can follow along too. We're on page 289. 289. So if you think back to chapter 1, and I asked you to find what alpha was, so if you have the sine of alpha is equal to 3/6, we actually know more than we did in chapter 1. Believe it or not, this is the same thing as 1/2. Wait a minute, where does the sine of an angle equal 1/2? Well, heck, I know that, right? The first place is in quadrant 1. So opposite, hypotenuse, adjacent. So what's the angle that's across from the 1/2? Pi over 6 or 30 degrees. Okay. Now, there is one problem though. We're talking about inverse functions. So let's remind ourselves at what the sine wave looks like. So the sine wave starts at 0. And let's go ahead. And we want to go out to 4 pi. We want to go backwards to 4 pi. Okay, slow down a minute. Oh, can't even see what I'm doing. It didn't even help to holler at me because I wasn't there. Okay, so the sine wave. Let's remember where the sine wave starts. I already put the starting point was at 0. Ooh, got bad glare. So, for the bad glare, we will do this so it's not directly on the light. Is that any better? Oh, much better. Okay, so for the sine wave, we start here. And, oh, that's not any better. And the period is 2 pi. And halfway in the middle, we're at 0. So that means this right here, and then we just keep filling it out. And we have our wave. All right. If you think about what I asked you above, I said, where is the sine of alpha? What alpha makes? Remember, alpha is the angle. The x-axis is our angles. what angle makes the sine wave 1/2? So if you looked at 1/2 and we drew a line right here, how many different places is that true? Well, in this, 1, 2, 3, 4, 5, 6, there's 8, and that's only 4 periods long. This goes on forever. So how do we know which one's the right angle? Well, we don't, unless they give us a little more specifics. But here's the other problem. This function is not even 1-to-1. It will not pass the horizontal line test, which means it technically does not have an inverse. Well, why the heck are we talking about this then? Huh? Why do we even have a whole chapter dedicated to inverses? Well, fortunately, some math ancestors of ours figured out how to make this work for us. They restricted the domain. Nice. I know you're really excited. Okay. So for the inverse function, what they did is they said, okay, we can't have all of it. We don't want all of it repeating. So they said they went from negative pi over 2 to pi over 2. So let's look back at your picture for a minute. So here's negative pi over 2. Here's pi over 2. So they said we're only going to look at this little piece right here. And if you look at that, just that little piece right there, guess what? You passed both the vertical, cha-ching, 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 and the horizontal, because we're only looking in this little tiny piece. So that's how they're going to let us deal with the inverse functions. And back down to our box. And they give us y equals the inverse sine of x. And remember, inverse sine is the same thing as arc sine. It is interchangeable. And they said it's equivalent to sine of y equals x. So if you look how they solved it, they just took the sine of both sides and got us back here. Now we need to remember this relationship for when we're solving our problems, because we will do that quite a bit. Okay. And in case you forget, where anything is limited to, if you look on your black bar sheet on the bottom below where phase shift and period were, they have a whole section all about inverse trig functions. I know right now this is really blurry, but right here we did sine. It said from negative pi over 2 to pi over 2. And there you go. So, what's the deal? Okay, let's keep going. This makes more sense when we actually do stuff with it. So let's take a look here. Let's look at some pictures. So what we're going to do for the sine wave is we're going to limit the domain. We're going to limit it from negative pi over 2 to pi over 2. So if you think about where it is at negative pi over 2, it's down here at negative 1. And so we're going to go from negative 1. And where do we max out at? We max out at 1. Crosses here at 0, and then there's our little curve. Okay, there it is. So that's the sine wave, and that's where we're limiting it. So now when we're talking about the inverse, what the inverse does is it switches our x's and our y's. So our domain is now going to be from negative 1 to 1. And our range is going to be negative pi over 2 to pi over 2. And if you think about this point right here is negative pi over 2, negative 1. So now we're going to go negative 1, negative pi over 2. 0, 0 stays the same. And this point here was pi over 2, 1, so we're going to flip it, and so it's going to become 1 pi over 2. And the curve flippies 2 goes this way, actually. There it is. The book does this much nicer, but there you go. Okay. Now, this seems pretty intuitive, but the important part is to pay attention when whatever is in this inside. So if you look here, the first part is the inverse sign is on the inside of the parentheses. So look at where we're restricted to for our x values. Versus when sine is in the inside, look at now where they're restricted to. And this plays an important role when we're doing stuff not only on our calculator, but also when we're doing them on paper. Because sometimes things are we're not allowed to do certain things. And the reason being is because of where we had to restrict our domains to make the inverses work. So if this is where we're at, this is what we need to pay attention to. If this is where we're at, this is where we need to pay attention to. And this is kind of our little shortcut. And that's on your black bar sheet, which is why I pointed that out. Okay. So let's look here at this explore and discuss. Let's actually explore and discuss too, but here we go. And so if we look on the inside, you always have to pay attention to the most inside function. That's the inverse sine. And it says inverse sine of 0.5. Are we allowed to have our value be 0.5 on the inside there? So look up here. Inverse sine, we're allowed to be from -1 all the way to 1. Well, that falls within that range. So in this case, the sine and the inverse sine will cancel out, and we'll be just left with this. Let me just try one thing here. And actually, if you type it in your calculator, it's another way to check. I went sine, inverse sine 0.5, and it worked. Okay? And the reason is because this is in the allowable domain. So here we go. Let's try this one. Now look here. We got to look at the inside. It's the inverse. Now does 1.5, is it within our allowable range? No. So do you think we're allowed to do this one? No. Let's see what happens if we do try. So we're going to go sine of inverse sine of 1.5. Quit domain error. Well, that makes sense because we just said it wasn't in our domain. So we would say does not exist, can't do, whatever. And so let's look here. So now we got to look on the inside. Is -1.3, is that within the allowable range? Our range is from -π/2. Uh-oh, what's -π/2? Anybody know it? Anybody know it? In case you don't, it's like -1.57. So, -1.57 to 1.57, that works. So this should be -1.3. Try it in your calculator. See if it works. Inverse sine. Inverse sine, 1.3. Ooh, -1.3. Oh, good. I got -1.3. Now, what about this one? Is this one going to work? Got to look on the inside. Nope, that's outside of our domain. So this one does not exist and will not work, cannot do. Okay. All right, so let's practice. We've only found example 1. Things go quicker from here on out, I think. So here we go. So it says, find the exact values, if possible, without using a calculator. So, here we go. So what I like to do on these is I say, okay, I'm going to let this equal y. And if I took the sine of both sides, I would have the square root of 3 over 2 equals the sine of y. We are more comfortable with it in this form, which is why we go ahead and change it like this. And now from here, I can actually use this information to draw my triangle. Now remember, when we looked at the sine, we're only allowed from -π/2 all the way to pi over 2. So if you think about that in terms of quadrants, that's here or here. So we're either in quadrant 1 or quadrant 4. And this is positive, so we must be in quadrant 1. So can we draw our triangle? Let's do it. Square 3 over 2, 1, 1/2. So what's our reference angle? What's this guy right here? Hopefully you guys are saying pi over 3. So that is what our y is. Our y is equal to pi over 3. There's our answer. Okay. Let us try this again. Over here. So I'm going to let this equal y. And I'm going to take the sine of both sides. So the sine and the arc sine cancel, so I'm left with negative 1/2 equals the sine of y. Now remember, sine, you're either in quadrant 1 or quadrant 4, and this one's negative. So we must be in quadrant 4. So there's our special. And what's our reference angle? Or what's our actual angle, actually? So it's pi over 6 is the reference angle. So that means our actual angle is negative pi over 6 because we went down. And there it is. You getting the hang of this? I hope so. It's kind of fun. All right. Now for C, this is where you have to look at what we're allowed. And the sine we limited from negative pi over 2 to pi over 2. So from negative 1.57, you can't see what I'm doing anyway, up to 1.57. That's in the range. So the inverse sine and the sine cancel, and we're left with 1.2. Ta-da! Okay. So let's just try this in the next one. Now this one's a little bit trickier because we have a cosine out here. We don't really know how to deal with him yet. So here you go. I need you to watch this, okay? Please pay attention. So what we're going to do is we're going to let y equal the inverse sine of 2/3. So in other words, the sine of y is equal to 2/3. Now this is not a special triangle, but that's okay. Because I let y equal this, what I'm really looking for now is the cosine of y. So can I figure out that ratio? Can I use this information right here to build the triangle? Of course. So what I did is I took this guy right here. Let me use a different color. I took this guy right here. I said, I'm going to let him equal y. And so then I replaced him. That's how I got this. And now this I'm treating just like I did up above. So I took the sine of both sides, and now I have this ratio of sides. So let's draw our triangle. And it's positive, so it has to be in the first quadrant. So this is 3, 2, see 9 minus 4, so square root of 5. And so the cosine of y, the cosine of this angle of this triangle is adjacent over hypotenuse. Don't worry, we're going to do more. Gosh, I love it. I'm letting you catch up here. All right, so let's look at this guy, the next one. So if you look here, 3 pi over 4 is not in our allowable window. But let's think about this. Do we know what the sine of 3 pi over 4 Do we know what that is? What is the sine of 3 pi over 4? Go ahead and draw your triangle. In quadrant 2, 45, 45, 90. And so it's actually 1 over the square root of 2. So if, instead of sine of 3 pi over 4, if I put in 1 over square root of 2, can I actually evaluate this? Of course. So what we're going to say is we're going to say y equals the inverse sine of 1 over square root of 2. Take the sine of both sides. So the sine of what angle is going to give me 1 over square root of 2? Well, 1 over square root of 2 has got to be in the first quadrant. It's the same special. And so our angle is pi over 4. That one's a little bit trickier. If you get a little bit stuck on this one, on page 293 is where you'll find that. And the last one for this example is kind of like what we just did in D, but I wanted to do it another time just to make sure we really understood. I'm going to do it on a different paper because it's getting kind of crowded. I really want you to be able to see what we're doing. So, oh, that looks a little better. Here we go. Here's what I'm going to do. I'm going to rewrite it. So it says the tangent of the inverse sine of negative 1 over square root of 5. Okay. Now, I do not know, I know that that's not a special angle with 1 over square root of 5. But here's what we're going to do. Here's what you do every time, okay? When you have two trig functions sitting like this, it looks kind of funky. So you're going to take the inside guy, and you're going to let y, you can let x, it doesn't matter, equal this. Well, if I let y represent that, then really now what we're looking for is the tangent of y. Okay, so take the sine of both sides. Okay, so sine is only in quadrant 1 or 4 because we're talking about, we start with this inverse. Okay, so it's negative, so it's in 4. Opposite hypotenuse. It should be 2. Double check me. Should be there. So what we're going to do is now we're looking for the tangent of this triangle. So the tangent is opposite over adjacent. So it is equal to negative 1/2. That's our answer. Lovely. All right. So we'll do one more example here, and then I have to go do some other stuff. And you've been doing this for 30-something minutes. So let's do the example 2, and then I'll give you problems to start with for the rest of the half hour. That means you actually need to do it. If you don't use your time wisely, don't complain to me later, and please substitute. Please write down if they were productive or not during the second hour. You just got to use your time wisely. It drives me nuts that you don't. So, here we go. So now let's get out our calculators. And we want to use 4 sig figs, and we're going to use radians. So here we go. So in your calculator, hopefully you can find the inverse button. Uh-oh. Okay, work on that for just a second. Sorry about that. Okay, so inverse sine 0.8432. Hopefully you got 1.003. Oh, back glare. Okay, all right, sounds good. Oh, it says arc sine. What do I do? Oh, phew, it's just the inverse. Okay, so inverse sine of negative 0.3042. Hopefully you got negative 0.309. And let's see what happens over here. I got a domain error. Oh, that's right. We're only allowed to be from -1 to 1. That was outside. So, does not exist. Can't do it. Bad. And so here, for cotangent, we're going to have to go 1 over tangent. Oopsies. 1 over tangent of the inverse sine of negative 0.1087. Now remember, this right here is finding the angle. This number right here is the ratio of sides. So what we're saying is we're going to say the cotangent of this angle, and this is telling me the angle. So that's why this works. And I got negative 9.145. And so here, this is the sine of angle of radian 2, so that's 2 radiuses around the circle. So if you do the inverse sine, and what this is going to give you, this is going to give you the ratio of sides. That makes sense, because when we use the inverse, we're trying to find the angle. So the inverse of the ratio of sides is the angle. You should get an angle of 1.14. Okay. So I have to go and do some other stuff. And if you look, cosine is pretty similar, except for the range is different. We're only going from 0 to pi. The other one was negative pi over 2 to pi over 2. So this one's 0 to pi. So if you would, here's what I'd like you to do today. I would like you to drawing these pictures from the book on page 295. Not asking too much of you. And then if you could go ahead and try let's see, what can you do? You could do 6, 12, oh, not 15. 15 is all special. Oh no, try 15. 18. 21. 33. Okay. So 1, 2, 3, 4, 5, 6 questions that I'm asking you to do. Take that back. We're going to add a couple more on. Only difference is these are in degrees. You should be able to handle that. It's not that bad. Okay, so here's what I'd like you to do. Page 295, and then I would like you to do these questions. Okay? Am I going to have you do the rest of them later? Well, of course. But here's what I'd like you to do for right now. So go ahead and write that down. Do that now. Don't wait until somebody needs to turn it off or check something. So do it now. Don't sit there and gaze out the window or gaze at your cell phone. So please use your time wisely. You should have about 20 to 15 minutes to get going on this. Good job today. Thank you. We'll see you tomorrow, if not later today.